Welcome back to the channel. I've got another video for you today, and it is going to be on retrofitting air blast to my older Haas. So 1997 Haas VF3. Now this is something I've recently needed when I was doing a job, but I didn't have time to get it set up, so I ended up just dragging an airline up to the machine, to the enclosure, over the top, and sort of just making something slapdash that worked, because I was actually using some Kennametal Harvey T1 or Harvey 1 TE end mills, and they recommend them not to be run with coolant. So I set up an air blast. Now I have actually got air blast on my other little VF0E. I've never done a video of it, but we've got air blast here. So it's good that I can show you this install. So this little tube here, so first off you've got your P-cool, and then this other tube here is for air blast. And I've done it like that so I attach it to here with cable ties so that I can move it up and down with the P-cool nozzle for where I want it. And it works really well. It's a simple install. It costs, well, the cost is minimal really, depending on what you've got or what you want to buy to put it in there, but it's cheap and cheerful. And the way I'm going to do it with this machine, because this machine's not located against the wall like that one, I have an airline. If I just might be able to show you, if I just look over in the corner, if you look just up in the corner up there, I've got an airline on one of them retractable hose reels. So for this machine, what I'll end up doing is creating the setup with something mounted on the back here that I can just, when required, I'll run that airline out along the floor and I'll connect it in. Because I think I'm going to be moving these machines, so I don't want to put in a separate airline, and I definitely don't want to run them on the same airline that feeds the machine air. I know you feed the fourth axis off the same line, but obviously that's going to be minimal compared to a constant air feed that may take away from the machine and cause alarm. So you want to run the airline separate, is my advice. So the components we need to do it: we need a power supply. Now, I bought this when I'd done the other machine, so I could have got this in a different voltage. This is a 12 volt DC clod valve. So this is basically going to be your open and close for your air, and this is going to be run off the auxiliary or optional M codes, the same as what I just used to set up the probing in my previous video. So we've got M21 on the optional relays. We've got 4 of them or 5 of them. M21 is already taken for your auxiliary M function. We've now used M22 for our Renishaw probing setup, so we can use M23. If we're using M23, that means it will be M53 to turn it on and M63 to turn it off. That way we can use the air blast, and you can also set up in Fusion 360 in your drop-down menu for your flood coolant. You can have flood, air blast, through spindle and all that sort of stuff. You can actually change that in your post-processor, so you can have air blast rather than coolant as and when you're posting out your programs. So we need a power supply, which again, this one I'd already previously bought is 12 volt. If I was to change this and buy another one of these and do it as 24 volt DC, I could probably take it off the same power supply that the probing uses, because it's never going to be active at the same time. So I could actually take it off of that, because that has got enough ampage that it will still run this. And as said, it will never be used at the same time as the probing. So I may look at changing this. If not, if you haven't got any power supply in there, this one is a AC to 12 volt DC converter. This one is 5 amps max, 60 watt. Then we've got our solenoid valve there. Then for the input, I've got a air coupling to, I think this is 3/4 BSP, so you'll have your air going in. Then I've got 10mm push fit going out, and I run the 10mm all the way almost to the P-cool. So I've got 10mm push fit adapters here. Then it reduces to 8, and then I use this tail reducer to reduce it to 6. and then I have a 6mm 90-degree fitting, which I'll come out of with a bit of copper tubing. And I've got a little bit in there, and I've actually got some more elsewhere. And then we've got our 10mm hard line there. So you don't need much to get this going. The only other thing you may need, or you may want, and I've actually got one in here, is, so this is like a open shut valve, like a reducer valve. Now, I didn't actually like them in the past because I found that they were far too restrictive in general. Now, what I've done on the other machine, because I mentioned about taking the air line off separate, what I prefer to do, my other machine air supply, which is here, this is purely for my air blast, separate line, is obviously I've got this valve. So I actually adjust what I want via here, and then I run the machine. Because obviously if you have this 8 bar, you're not going to want that, it blows stuff everywhere. But I set it to here as and when I'm running the machine. Now, that's not the most simple way. It will be nice to have it something a bit smaller, but I only tried 2 styles of valve, and I mounted them just behind the machine there. But them 2 styles of valve I found restrictive. So my idea of doing it is to run the valve off the main airline. I prefer it personally, you may not, so that's up to you. So yeah, this video is about installing air blast, because I've got some jobs coming up on some steels and some stainless steels, and I want to be able to run air blast rather than the little slapdash setup I've done before. So we're going to mount this on my other machine. I've basically mounted it somewhere like that. It's off the side here, either a bracket or even a cable tie will do, because nothing's pulling on it. And then we can run a 10mm pneumatic hose up there to the head, and obviously we can just connect our airline into here as and when we need it. And then coming off of that, you've got your cables, which is your power. Now, all you need to do for your power is to run your common into your power supply, and then from the power supply you're going to go from your power supply into the relays. You've got normally open, normally closed, and your common. So you'll just run this through that, and then that way when you use your M code, which in my case, what did I say, it'll be M53 to turn on, M63 to turn off, that's going to activate your air blast. So yeah, it's a good mod, and it's well worth doing if you do a lot of steels. So I'll get this started to be wired up, and I'll bring you back. Okay, so we've got the power supply in, and the wiring from the power supply to the board to the air solenoid. So I'm going to show you that now. So you'll see this power supply, and this is the same one we used before on our Renishaw setup. On this occasion, this is 110 to 220 input, which you'll see I took from up here on the main power supply board. That is 94 and 95. That gives me 110 into the power supply. There is a switch in here that you have to select, telling it what you're putting into it. So I've switched it to 110. And then this gave 24 volt DC output, which run my probe setup. Now this had 2 outputs. So the red and the black is running the probe, and the 2 brown is now going to run the solenoid. So that will come up and out to the solenoid, but you can't run direct to the solenoid or it will be turned on at all times. So you need to come up to your board and connect to one of your optional relays. Now, the earlier boards only had 4, M21 to M24. The later boards, like in my VF3, they had M21 to M25. But M21 is always used for your auxiliary M function, so that one's already gone. Then M22 is gone for the probe setup. So on that machine, Air Blast is M23, because I've done this conversion on that about a year ago. And I'm going to use M23 on this machine as well. And the reason to making sure it's the same is because in Fusion 360, you can alter your post processor. Well, I use Fusion 360, but you can probably do it in all them. But you can alter your post processor under your drop-down menu where you've got flood coolant, through spindle, all them sort of things, there is one for air blast. And you can change in your post-processor what it is and what it outputs, and mine will output, when you're using, I mentioned this before in the Pro video, if you use M23, for example, like I'm going to, for some reason, turning it on is M53 and turning it off is M63, because you can't use the M20s. They must be designated for something else already. So M23 to activate is M53 and to deactivate is M63. So what you need to do is you need to have one cable. This is already fused inside. The probe setup had an extra fuse in there because that's what the probe manual said. As far as I know, that's not required for the air solenoid. They don't come with any instructions in the box. They just basically say you can put power to them and cycle them that way. And this is already fused. So correct me if I'm wrong, but there's no fuse run to the valve in this sense, in this setup, sorry. So you've got a positive and a negative. Now I've run the negative straight to the valve, and it hasn't got any specific polarity, so it can run to either wire on the valve. And then the positive has to be able to be turned on and off by your M code. So one of the cables comes along, up, branches out into my conduit here to my board and goes to M23 common. Then you put another cable to M23 normally open. The older boards only have common and normally open on the M23 and M24. Don't know why. M21 and M22 has common, normally open, normally closed. And my board, the later board on my VF3, they all have normally open, normally closed. So obviously there's different editions of board, but we only need normally open. So yes, M23, one wire goes to common, then another wire comes out of normally open, runs out, comes up here, and I've gone through here to the valve. So that is all that is required for the wiring. It's very straightforward. Now, for my cables, I've just come out the back here, and this is what I used. It's 1.5mm electrical cable. It's probably overkill, but I'd rather be overkill than underkill. These are your two cables coming from your valve. Again, there's no polarity. It will connect either way. And I've just used spade connectors. You could do solder joints on this to make it a bit nicer, but this will do me. It allows me, if anything happens to the valve, it's quick and simple for me to plug it back in and get a new one. So here's our setup. Now this is what we're going to run. So we've got the valve. Obviously the air direction is this way, so this will be the outlet, which is a 10mm push fit. The inlet is one of these gas type open closed valves, and then we've got a PCL airline adapter. Now the reason I went for the open and closed valve like this, which you might think is a bit bulky, is because the smaller inline pneumatic style valves, where it's like a screw adjustment, they tended to be really restrictive when I tried them on the other machine, and even when they were fully open, it didn't give the best airflow. So although this is a lot chunkier, you can adjust the airflow when it comes in first to what comes out. Now, yeah, you've got to walk to the back of the machine to adjust it, but once you've got it set, you'll probably use the same airflow for everything you do. And it's very quick and simple. So it's not like it's going to cause you any grief using this sort of valve over something that you come over and fine adjust. This way you can get plenty of airflow because you will put in exactly what's coming out the compressor wires. You can open for that. And again, it's separate to the machine because you don't want to put so much air through the air blast, you shouldn't do, but put so much air through the air blast that the machine drops low. Now my compressor can cope with more than these machines very easily. But don't take it off the same airline that feeds direct to the machine, because on these old ones it's probably not a good idea. Newer machines have got a separate cabinet with all their valves, and they've got all the air valves and that built in. So this sort of setup only really applies to the old stuff, which is all I tinker with. So anyway, we've got our solenoid there, we've got our valve, which is our open close, nice and simple, and that is a push fit for our output. Now what we'll have is other cables here, step down. This will be the air blast nozzle we're going to use, which is just 6mm copper, which obviously you can cut and use different lengths and sizes for different jobs. So what I'll do is I'll go get an air line now. I'll connect it up to here and just leave it hanging on the side, and we'll go do a bit of MDI and we'll test that the valve is actually open and closing. So let me get the air line and I'll come back. Okay, so we've got everything hooked up on the machine now. We've got the bracket mounted. So the bracket's mounted on there. There's your button head bolts that go through there so it doesn't chafe any wires. Be nice to get I think this is 1/2 inch BSP 90 actually, so that this hose came down rather than sitting off there, but that's plenty strong enough to come off there. You could always clip it up if it was going to be there long term. We've got our valve. Because it's mounted, we can easily open and close it. So I'll have it open about there. And then we've got our push fit tube. Cable tied to here. I didn't want to drill into this because the cable's further down, I can't see them. Definitely didn't want to risk catching a cable. So I've cable tied that as a safer option. And as you come round here, if I climb up on the machine to show you, we used cable tie saddles and we've cable tied the tube there, and then we drop down to 6mm, comes along there, and then we go into a 90-degree fitting, and then we've got our 6mm copper tube just pushed into there. Now this one tends to line up nice straight to this tube because of the way it comes out of there. This one, because we've got this big fitting, it doesn't really want to sit flush, so it's not quite as sturdy. So I'm going to change something there. But again, it still works. It's attached to the P-cool. So we can use the P-cool to aim the air blast up and down. And we showed working before. But again now, if we was to be running a program, it would be M53. Turn her on. And there we go. Probably a little bit too powerful on the air there. We could turn that down a bit. And of course you can run a shorter bit of this, you can run a longer bit of this. You could probably even find out where to get these sort of cylinders that Haas use on the new machines, that when the air comes on they extend and then they blast air, and when the air's turned off they retract, because that's a pretty cool feature. But I'm not sure where to get one of them other than Haas themselves. So yeah, that works perfect. Everything's fitted in there. That's a nice addition to the machine, and it doesn't take long to fit, which is nice. So I've tested the solenoid valve because some programs on the other steel jobs I do, I've been running some mild steel on this today and doing a bit of broaching and stuff like that in the mill. But I run coolant on the mild steel. It's not as much of an issue on the generic cheap steel end mills. But for like the P20 tool steel, I was running that dry with the Kennametal Harvey 1 TE end mills. And some of the cycles were 20, 30, 40 minutes long. And I was a bit concerned about the duty cycle of the valve. Now I've checked this valve and we wrote down that obviously when the coil has power to it, after half an hour we was at 45 degrees Celsius. After 1 hour we was at 55 degrees Celsius, and after 3 hours we was at 60 degrees Celsius, and that's pretty much where it stayed. And I think I turned it off after 3.5 hours. Now that was with no air running through it. That was with me just activating the valve with the airline disconnected to see. I can't find a duty cycle for it. So I'm trying to contact the company and see if they do an option which has got 100% duty cycle. So basically if you were running this all day, because the only time it will turn off is between tool changes. So if you've got a program running all day and you're doing an 8-hour shift, you potentially want the duty cycle to be able to be on for pretty much 8 hours. So I'm going to find out some more info about that. But I'm going to actually offer, once I find out about them duty cycles, I'm going to offer these as a kit to purchase for an air blast. So you can put them on any machine probably, if it runs the same way, as long as you've got a relay output. So I'm going to do these as a kit, which will include the AC to DC power supply. It will include one of the two-way solenoids, the pneumatic tubing, the fittings, the copper pipe, the cable ties, the saddles, everything bar the wiring, because I don't know what they're going to be fitted to. So in that sense, all you need is some cable and some crimp terminals. So I'll leave that to the people who do it. But I'm going to offer these as a kit. On my website, I've just done a website, which is kinseyfabricationsandmachining.co.uk or .com. And you can also get to it via kinseyfabrications.co.uk and kinseyfabrications.com. All four of those domain names will take you to my website. I've got a section on the website which says CNC replacement parts, and there's loads of bits and pieces that I'm offering on there which are compatible with the older Haas machines. Now, I don't know about new machines because I've never had one, but all the old stuff that you see on my videos, I've got stuff on there which is compatible. It's not manufactured by Haas, it's not supplied by Haas, the parts that I've got on the website, but they are compatible with Haas, older Haas mills. Maybe some newer, I can't tell you on that front. Things like limit switches, what have I got on there? Tool changer parts, limit switches, there'll be an air blast kit, there will be tool changer bits and pieces, all sorts of things that are compatible, and I'm going to do it over time. Now, also on the website, I'm actually going to have, I've teamed up with Aaron, who is CNC Repairman, if you've seen him on Instagram and on YouTube, and he's got a website in the US called cncreplacementparts.com. Now, he does absolutely loads of parts for new Hasses. He's a technician. He's got his own company doing machine repairs, call-out servicing. So he knows miles more than I do. But he wanted an outlet in the UK, and I'm going to be an outlet, one of, or the outlet for his parts in the UK. So anything you see on his website, sooner or later you'll be able to get it through me on my website. So yeah, take a look, and anything that goes through there, obviously it helps me out as part of the business while I'm doing all this stuff on the machines. So yeah, thanks again for watching. Please like and subscribe if you like the content, and we'll see you again on the next video. Next one, hopefully, should be update on the spindle. The spindle's obviously back over here, but we're waiting on the shrink fit collars and the bearing spacers because I sent them off back to Midland Machine Tool Recon to be ground and a new shrink collar to be made because the pitted one was ovaled and it was in bad condition. So we decided, the guy said, you're better off making a new one, so they've done that for me. So hopefully that update will be soon and we can get a new spindle in the machine. So yeah, cheers for watching. We'll see you again soon.